Okay, let's see if we can move beyond the triangles a little bit. So I want to do another example now. I'm going to do something which seems very basic, but we're going to have to think about it a little bit differently in GLSL. So I want to draw a circle, actually. So here's what I'm going to do. I'm actually going to set up a square. So I'm going to put vertices at all the four corners, actually. Remember we have this coordinate system. So I'm going to put vertices at all four corners. And I'm actually going to connect them with two triangles. So my index buffer now actually has two triangles. So I have my upper left, my upper right, and then my lower left and my lower right. And so this says connect, make a triangle between the upper left, the upper right, and the lower left. So that would be the triangle we already have. But I also want you to make a triangle between the upper right, the lower left, and the lower right. So that would be this other triangle here. Okay, so it's going to draw two triangles. How does that have to do with drawing a circle? Okay, we'll see in a second. But okay, so, and that's all we need for the buffers. But now, okay, so I want to draw a circle, and the circle is going to have a particular radius. So somehow I have to pass the radius over. I could, make an attribute for the radius and just say the same thing over and over again. So, I could make a buffer with the radius repeated 4 times. But there's something better I can do if I want a piece of information to be basically a constant once the shader starts. So for that, we declare something called a uniform variable. So radius is a uniform. What that means is it's the same over all my fragment shaders, over all the pixels that my fragment shader works on. And also my vertex shader, if I want to use it there. Okay. And so the syntax for that, actually you don't even need to use it in both the shaders here. Notice that this vertex shader looks very similar to the one that we saw in the triangle, except instead of a color, I actually said I want to move the position by barycentric coordinates. Okay, so I start off with these 4 positions at the corners, and I basically am going to interpolate them to some entire grid here. Okay, so that's what that does. But the more interesting thing is going to be this fragment shader. So notice we've added a couple things. So we don't just have this position that gets interpolated. So we do, we have that's a variable, but we also have these uniforms. And actually another uniform that I'm storing is time. So for each frame that we draw, we could say, hey, here's the time that this frame is being drawn. Broadcast that time to all the pixels. So that's what these really are. We're broadcasting information to all of the pixels. And so what we can do is we can say, okay, out of this V position, we can extract an X coordinate and a Y coordinate. So this is going to be my interpolated position at whatever pixel I'm at. Okay, so somewhere on this grid, it's going to be, okay. And what I can do is I can say, okay, well, I mean, right now this program's not going to be too exciting. If I go to run it, circle.html, it's going to draw all black. But what I can do is say, well, look, you can draw black if you're outside the circle, but if you're inside the circle, I want you to draw red. So now we just need to remember the equation for a circle. So what I'm going to say is, okay, I have this radius that's been broadcast. It's uniform to all my pixel shaders. That's the same for every pixel. What changes at each pixel is its position that we figure out by barycentric interpolation. So what I'll say is if x times x plus y times y is less than the radius squared, right? So remember the equation for a circle that's centered at the origin is x squared plus y squared is equal to the radius squared. So if we want to be inside the circle, then we should be less than or equal to the radius squared. So we'll say if we're inside the circle, then we'll draw red. So this is our only output, actually. This is something that actually makes shaders a little bit difficult to debug. The only output we have is a color at every pixel. So you have to sometimes get a little bit creative with how you debug. And I'll explain some strategies in the next module. But okay, but let's do what I said. So if I'm inside the circle, I'll draw red. So 1.0, so that's fully saturated in red. No green, no blue. I haven't talked about this too much yet, but you have a fourth coordinate here, which is called alpha. For now, just make that 1. It's transparency. Okay, so there are more fancier things you can do, but right now we just want to be red inside the circle and black outside of the circle. Boom, there it is. Okay, very exciting. We have a circle. Now, if I go into this JavaScript file and I change what gets put in the uniform, I can make that circle bigger. I can make it smaller. I could also choose to add an offset to the circle, right? I could say, well, let me pretend I move my x over by 0.5. So that actually moved it over to the right. So remember when we subtract, we actually move to the right because it takes longer to get there. Okay. And then I could move the y up. Or sorry, that moves it down, right? Because when I add it goes down. Okay. So I moved it to the right and moved it down, so I can do that sort of thing. But here's where it gets really cool. So I can actually make animations if I want to. Because I can make time uniform. So what I've done in this JavaScript file here is that I've actually kept track of time elapsed since the beginning of running this thing. And I've copied time over as a uniform. So this holds the amount of, I believe, milliseconds, or maybe it's seconds, I can't remember. I think it's milliseconds. Actually, let's log it out to the console real quick just so we can see. So if I log console.this.time, okay, if I pop an F12 here, okay, it's seconds. All right, so this is the time in seconds elapsed since this thing started drawing. And actually, one more thing I'll point out real quick, which is just for your edification, but the way that you keep an animation going in JavaScript is with this request animation frame. This says, as soon as you get a chance, call this function. And so what it is, it's going to call this render over and over again. Because I'm saying, as soon as you get a chance, call me again. So it's like infinite recursion, basically. As soon as you get a chance, call me again. As soon as you get a chance, call me again. As soon as you get a chance, call me again. Every time I call it, it's being updated what the time is. So that uniform is being passed along to the fragment shader. So what we can do, for example, is say, hey, you know what? I actually want to shift my position by the time. So I guess I'll move this to the right by time. See, there it goes. Whoa, it's gone. Okay. Maybe I'll say, make that move a little slower. So I'll say 0.1 times time. Okay, so there we go. It's drifting it over the right. So what's cool about this is it's happening very quickly, right? I don't have to go in a loop pixel by pixel on the CPU to draw a new circle each time. Actually, these frames are being drawn real time because every pixel in each new frame is being processed in parallel. Okay, so that's kind of neat. I could even, say make this a cosine. So cosine's built in. So I can say, take the cosine of u time. And now we should see the x go back and forth. So that's pretty cool. I can make it oscillate faster. What did I do? I put a 10 times cosine. What's it going to say? Could not compile shader. Why? Because because wrong operand types. No times exist that takes a left-hand operator into the right-hand operator to float. Okay, remember, it's not 10, it's 10.0. Okay. Anyway, so now I got this thing oscillating quicker. I can make it oscillate slower, and so on and so forth. Oh, now it's really just creeping along there. Okay, so that's really the basics of animation using shaders. And so I'm just going to have you do just a quick exercise on that now. And then we'll move on to one last thing in our basic shader unit.